Hello. So I fixed the animation orientation. There's still a lot of stiffness to the animations, and I'll go ahead and fix that in the near future. It's just the massive difference between the ready stance and the walking stance, which makes it look super stiff, but I know how to fix that, and I'll fix it later. The way I fix the orientation problems is that here in the Blender file, when you are clicking on one of these animations, you actually have to loop the pose, and you have to change it from body orientation to original. I'm not entirely sure why that works, but it does. And you also want to turn off root animations, root motion here in the animator. Those two things combined fixed my problems, and I don't know why that is. So sorry about that. If someone out there knows a lot more about how Mechanim works, maybe they can tell you. Either way, it's now time for us to talk more about the idea of actually having the attack do something. Now, in order for an attack to actually hit something, there has to be a moment in the attack animation where it does something. So if we were to expand this a little bit here, I guess that's expanded. So if we were to run this forward, we want it to hit. When it hits here, we want it to go bang, we're hitting something. So what we're going to do is we are going to add an event. Here in the events part of this, make sure that you're on the right and correct animation. It's easy for it to just randomly switch which animation you're on. You can see this red mark that identifies where we are down in the preview window, so we can really tell exactly when we want it to hit. And that looks good. So let's add a new animation event, which we will call Attack Light. That's all we need to do, but we do need to make sure it's at the right spot. And it is, because it gets added wherever the red bar is. So there we are. We now have an event. Easy enough, right? So when we hit play, we have to apply that. This takes a little bit of time. Importing Blender files takes a while if you've got animations. Unity's animation importer is not the fastest thing around. There we are. So now if we were to go over into the console here, and then, where's my mouse? Not sure what happened there. Let's try that again. And click. You can see how it says, wait, there's no receiver. What the heck are you doing? Well, that's fine. We'll make a receiver. Now, normally, I mean, ideally, I would like that receiver to be part of the avatar controller, but as it turns out, that's not possible because they're on different objects. This is the object that we are going to be getting the events on, and this is the object with the animator controller on it. So, sorry, with the avatar controller on it. So the animator is on a different object, and we have to add our new object here. So let's create a new script to catch all of these events. We're going to call this an avatar animation responder. And the reason that it has such a long name is because there's going to be a lot of kinds of animation responders, probably one per class, maybe even one per enemy type, depending on how we script it. So we need to have these names be very specific. And we're going to just drop that onto the correct object. So there's our animator, and here's our animation responder. And we can open that up in our editor of choice here. Since we do require an animator, let's go ahead and put that in here so that we don't ever screw that up and forget. So the avatar animation responder does not have any start or update functionality, at least not at the moment. And all we have is public void attack light. And our thing we're going to do is just say debug.log whap. Easy enough, right? Here we are, back in the game. Let's hit play. Look at the console. Whap. Whap. Well, now our whapping is working, but we would like it to actually hit the enemy, right? It's only been 4.5 minutes. I think we can probably manage that. So in order to make it hit the enemy, we've got to give it a hit location. And in order for that to happen, what we're going to do, we've got a couple of options as to how we would like this to happen. The simplest way to do it is to use a spherical object. And since there's no particular reason to have that spherical object, we can make that spherical object a collider, even though it wouldn't necessarily be, you don't actually need it to be a collider. You just need it to be a point in space that has a certain size. But if we make it a collider, we can see what the collision is. On the other hand, if we make it a collider, then there's more calculations involved. So what we're actually going to do is we're going to make it a sphere. And the reason for that is because I can still see the radius if I look at the sphere, and then I won't be... it'll be a sphere without a collider. It won't have any physics effects. We won't have to worry about it constantly checking things. And if we've got 50 of these guys, it won't take up any much extra space or time. So where do we put the sphere? Well, one option is to attach it to the sword. However, that's not necessary. We don't have to do it that way. We can instead put it out here, because we know that that's where the sword will be, and give it a nice big radius, like, you know, just anything in this general vicinity will get hit. And I think that's probably a better option. So let's go ahead and create ourselves a sphere. There is our sphere. It starts with a sphere collider, so remove that. And let's just move this into position, like so. And we'll call this the attack light hit. Now, the best thing about using a sphere is that the radius is built into the scale, so we can use the local scale as an understanding of where we're going to hit. And does that seem right? Well, let's find out. We can Control-Shift-P upon attack. And if we go over to our character, yay! And we just step forward, you can see that it's a little bit too close to the body. We could either make the sphere larger or we could move it away from the body. It really doesn't matter at this stage. But this will work fine. And then what we can do is we can just disable the mesh renderer or even disable the entire object. It's up to us which we would prefer. I'm going to go ahead and just disable the entire object because that's cheaper. And then what we're going to do is we're going to make that something that we understand here in our avatar animation responder. Public float, public transform attack light sphere. Eventually we're going to have to turn this into a much more complex system for actually adding arbitrary attacks, but that's off in the future. We're not going to worry about it right now. Attack light hit sphere. There, that's what we'll call it. Here in the debug.log WAP, what we're going to do is we're going to try and figure out if there is a target, an enemy, within our attack light hit sphere. Now, there's a lot of ways to calculate out whether there's an enemy in a given location. We could use ray casting if we had a specific ray that we planned to hit with. There are a lot of other options. In our case, what we might want to do is just request all of the hittable objects in the scene and look and see whether or not they're close enough to actually qualify. The problem is that this is all quite slow. Panning through the scene for every single object to try and find one that makes sense, it requires you to actually pan through the entire scene. We're going to do it like that for now, but once we start to add things like buildings, rocks, trees, NPCs that aren't enemies, swords, whatever, all of those things will slow this down, and it's going to be important for us to change it out later. So I want you to know that this is not the way we're going to be doing it in the long run. In the long run, we're going to keep a list of enemies, but for now we'll do it this way. And this way, of course, is game object, or it might be transform, I don't know. Targets equals game object dot find game objects with tag. And now we can go ahead and give it whatever tag we would like, let's say enemy. And that will get us all of the objects that have been tagged enemy. So if we go back over here, we've got a lot of these guys here, but they're not really enemies, they're untagged. So we've got to tag them. And there's no enemy tag, so we have to add it. There we are. Now we've added the enemy tag, all we have to do is actually tag all of these as enemy. Later on, we are not going to be using this. I just wanted to make clear that that's definitely not how you'll do it in the long run, although the enemy tag will be handy for a lot of other things. So we've now tagged them all as enemy, and we can go through each. One of the things we can do is we can check for bounding boxes, we can check for collision between our spherical area and their bounding box, or we can just check and see whether or not they're with the core of their body is within our bounding box, or bounding sphere, which is generally going to be faster, so that's what we're going to do now. Later on, we may change it out so that we actually take into account various colliders involved for multi-part enemies or something like that, but this will work fine. So we just say vector3 delta equals targets a dot transform dot position minus attack light hit sphere dot position. We say delta dot magnitude is greater than attack light hit sphere dot transform dot local scale dot x. We'll just use x. It's arbitrary. It's going to always be spherical. So if the magnitude is less than that, less than or equal to that, that means we hit them. So we want to say debug.log whapped, and then we can give the name of that particular target. So over here, we are going to go ahead and see if that works. Oh, look at that. It has crashed, probably due to an infinite loop. Nope, it was just really slow. Oh, we forgot to assign that's the problem. Gotta remember to actually finish the things you start. There we are. That should help. So we didn't hit anything, but if we run over here and we hit this guy, you can see that we whapped the slime. Now, we are checking against the slime's center, which is actually right there at the bottom. So we're going to modify this so that it actually strikes at a place that's more useful to us. So if we make this 1.5, 1.5, 1.5, this makes more sense. So this will work. And then we'll disable it again. But we want it to actually injure the slime. So what we're going to do is we're going to say, what's the name of our enemy unit script? Battle unit. There it is. We're probably going to have to make a version of the battle unit which is enemy specific, but that's okay. Battle unit BU equals targets a dot get component battle unit, and we say if BU equals null, debug.log, or debug. We want it to be more than a log, debug.error. That target is tagged as an enemy even though it isn't one. Return. Continue, I guess, would be a better option. And then down here we say bu.hp. And remember how we can just subtract HP? How nice is that? We'll just say minus equals 1 for now. Go back over here, hit play. Whap, whap, whap. Oh, see, we don't have a heavy hit, so we've only got the light hits, and the light hits work fine, but they do take a while. So what do you say we just take the next 2 or 3 minutes here and add in a heavy hit? There's not going to be any more surprises here. We're just going to go and do the exact same thing, but for the heavy hit. So in the inspector, we start up the heavy hit as our class, or as our animation of choice, and we move forward, and this is a good spot for us to actually trigger the hit. How about right there? So we just go down to the events, we add the event in, we'll call it attack heavy. And there we go. So we of course have to apply that, which takes a little bit of time, but while that's computing, we can go over here and just copy this whole thing and paste it and make it into attack heavy. And we have the option of changing out the attack sphere for a new sphere, but in this case I don't think we're going to bother. The attack light sphere can play double duty for now. And then instead of saying whapped, we're going to say whanged. And we're going to subtract a lot more HP, like say 4, but we're also going to make the slime fly away. So targets a dot rigid body, or I guess I can say bu dot rigid body, dot velocity, and then we can add in our forward vector. So we just say transform dot forward times 5, plus transform dot up. That ought to do a little bit. Obviously, we're winging this. Later on, we'll need to actually have data-driven stuff there. But for now, let's go ahead and see whether that worked. There's my normal whap. Whack. Okay, so they did not react to the rigid body change. The reason for that is, I think because they don't have rigid bodies attached anymore, do they? Well, they do. Something about that is not correctly handling the rigid body thing. It may be that I'm overriding the position somewhere in the mob AI or something. It's been a while since I looked at it. Let's just take a quick peek. It's definitely not there. We don't affect the rigid body anywhere in here. I'm not sure why the rigid body isn't getting properly affected, but I can always work that out later. The point is... Oh, did I set it so that it's... No? Yeah, not sure why that rigid body isn't working. But the attacks are working. We'll get the rigid bodies working later. Anyhow, you can see that using the event system, it's pretty easy to set up events at any given point on the animation. And it's also easy for us to do things like have a whole bunch of animations, or a whole bunch of events within one animation. If we've got like a flurry attack, it works great. Wham. Wham. The rigid body is really needed to make that actually seem right. Now these slimes actually do have a flinch animation, but it doesn't get triggered. So maybe I'm not sure exactly what we'll do in the next episode. There's a lot of things to do to start to flesh out this battle engine, but our attacks are working, and we can hit multiple enemies with a single blow if they're crowded together well enough. And all in all, it's nowhere near fun. But it is near being near to fun.